Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Edward Witten's 2000 lecture, titled Quantum Field Theory and String Theory, delivered to an audience of mathematicians, stands as a capstone intellectual statement summarizing the profound transformations in theoretical physics during the preceding decade. It functions less as a conventional research paper and more as a powerful, unified thesis articulating a new vision for the relationship between these two monumental subjects. The work's central, revolutionary claim is that the long-standing conceptual division between quantum field theory and string theory is an artifact of a limited, perturbative understanding. Instead, Witten posits that in many crucial instances string theory, or its encompassing framework M-theory, provides the complete and precise non-perturbative definition of certain quantum field theories. This essay will undertake a direct, section-by-section evaluation of the specific claims, frameworks, and logical arguments presented within this landmark exposition. It will trace the architecture of Witten's reasoning, from his foundational re-evaluation of quantum field theory's nature to his articulation of duality, deep brains, and holography as the essential mechanisms revealing this deeper unity. The analysis will focus overwhelmingly on the internal coherence and intellectual force of the arguments as presented in the 2000 work itself, assessing how each component contributes to the construction of his overarching conceptual edifice. Section 1, the re-evaluation of quantum field theory's foundational status. Witten commences his argument by directly addressing the perceived status of quantum field theory. His initial claim challenges the textbook conception of quantum field theory as being synonymous with the machinery of Feynman diagrams and perturbation theory. He posits that this view, while extraordinarily successful for computations in theories like quantum electrodynamics, represents a mere asymptotic expansion around a trivial vacuum. The core entity, the quantum field theory itself, remains a more profound and elusive mathematical object whose full definition is unknown in most four-dimensional examples of physical interest, such as quantum chromodynamics. Witten's argument here is one of conceptual reorientation. He asks the audience to view quantum field theory as a fundamental, yet largely unsolved, problem in mathematical physics. The purpose of this initial framing is to establish a central intellectual tension. We possess an incredibly powerful calculational framework that we are unable to define rigorously in the cases that matter most. The evidence he marshals for this claim is the very existence of phenomena like quark confinement in quantum cryptodynamics, a quintessentially non-perturbative effect that is invisible to any finite order in the perturbative expansion of the Strom coupling constant. He presents the Millennium Prize problem concerning the existence and mass gap of Yang-Mills theory as a formal testament to this foundational gap in understanding. By establishing quantum field theory as an incomplete project, Witten creates the intellectual space for a new tool or framework to provide the missing definitions. His specific claim is that the path forward lies in finding exactly solvable models that, while perhaps physically unrealistic in their details, can provide structural insights into the behavior of all quantum field theories. This sets the stage for the introduction of supersymmetry. Section 2, supersymmetry as the indispensable analytic tool. Following his diagnosis of the problem, Witten introduces the core therapeutic instrument, supersymmetry. His central claim in this portion of the argument is that supersymmetry, the symmetry relating bosons and fermions, is the crucial ingredient that enables physicists to move beyond perturbative approximations and make exact, non-perturbative statements about quantum field theory. He evaluates its mechanism with precision. Supersymmetry drastically constrains the dynamics of a theory, causing profound cancellations among quantum corrections that would otherwise destabilize the system or render calculations intractable. The power of this mechanism, he argues, resides in its ability to protect certain quantities from receiving quantum corrections at all. He presents the calculation of BPS state masses as the prime exhibit, BPS states, named for Bogomolny, Prasad, and Sommerfeld, are special states in supersymmetric theories that preserve a fraction of the supersymmetry charges. Witten's claim is that the masses of these states are determined exactly by the theory's classical parameters and are invariant under changes in the coupling constant. This provides an analytic window into the strong coupling regime, a domain traditionally shrouded in mystery. He explains that by tracking these protected BPS states as one dials the coupling from weak to strong, one can obtain precise information about the theory's full, non-perturbative spectrum. This is a radical departure from conventional methods. The argument is that supersymmetry transforms quantum field theory from a subject of approximations into one capable of yielding exact, analytically controlled results, at least within this specific class of theories. Witten's evaluation that the insights gleaned from these exactly solvable supersymmetric theories are so profound that they offer a template for understanding the structure of more general, non-supersymmetric theory. Section 3. The unifying principle of strong-weak duality armed with the tool of supersymmetry. Witten next deploys the concept of duality to begin dismantling the conventional divisions within physics. The core assertion here is that duality represents a new kind of physical equivalence, one that identifies seemingly disparate theories as different descriptions of the same underlying physical system. He focuses on the canonical example, the Monton and Olive S duality in n equals 4 supersymmetric Yang-Mills theory. The claim is explicit and startling. This theory, which describes the interactions of gauge bosons and their superpartners, possesses a symmetry that inverts the coupling constant, mapping a value g to its inverse, 1 divided by g, up to a factor. This strong-weak duality has a profound physical consequence. It equates the elementary particles of the weakly coupled theory with composite magnetic monopoles in the strongly coupled version, and vice versa. Witten presents this as a complete dissolution of the distinction between elementary and composite particles, a bedrock concept of 20th century physics. The argument's force comes from its specificity. He explains that this symmetry is part of a larger group of transformations, the special linear group of 2x2 matrices with integer entries and a determinant of +1, which acts on a complex combination of the coupling constant and the theta angle. This mathematical structure, he claims, governs the full non-perturbative behavior of the theory, binding all possible coupling strengths into a single, unified modular space. His evaluation of the evidence, rooted in the matching of BPS state spectra, leads to the conclusion that duality is a fundamental principle of nature. It implies that a description of a physical system is always context-dependent, a specific viewpoint, within a larger web of equivalent descriptions. This claim radically reshapes the goal of fundamental physics from finding a single, ultimate theory to mapping out the entire network of dual theories. Section 4D brains as non-perturbative dynamical objects. The argument transitions from the abstract principle of duality to a concrete physical object that embodies these non-perturbative effects, the D-brain. Witten's central claim in this part of the lecture is that D-brains, first understood as specific boundary conditions for open strings, are in fact full-fledged dynamical objects in their own right, as essential to string theory as the strings themselves. He evaluates their nature by explaining their dual definition. Perturbatively, a D-brain is a subspace where open strings can end. The vibrations of these open strings, he argues, give rise to the particles of a gauge theory living on the D-brain's world volume. This provides a remarkable mechanism for realizing gauge theories within string theory. His deeper, non-perturbative claim is that D-brains are also sources for the fields of supergravity, analogous to how an electric charge sources an electric field. They possess mass and charge, and their dynamics are governed by a specific effective action, the Derek-Born-Feld action. This dual character is the crux of his argument. Deep brains are simultaneously the stage for perturbative open string physics and heavy, non-perturbative solitonic objects within the closed string theory of gravity. Witten's analysis of this dual nature leads to a profound conclusion: the massless gauge fields living on a stack of n coincident deep brains correspond precisely to a UN gauge theory, with UN being a unitary group of degree n. The claim is that string theory, through the dynamics of deep brains, engineers gauge theories. This provides a powerful, constructive link between the two subjects. His evaluation is that the existence and properties of deep brains are essential for the consistency of string theory's duality, web, providing the necessary states to complete the BPS spectra, and acting as the fundamental building blocks in M theory, section 5M theory, as the 11-dimensional unifying framework. Witten next synthesizes these elements duality and deep brains to construct his argument for a single, unifying theory in 11 dimensions, which he refers to as M theory. The central claim here is that the 5 consistent superstring theories known in the mid-1990s, namely Type 1, Type 2a, Type 2b, and the 2 heterotic string theories, are themselves merely different perturbative limits of this single, underlying 11-dimensional framework. The argument is one of deep unification, demonstrating how apparently distinct physical models emerge from one source. He presents 2 key pieces of evidence. The first is the relationship between Type 2 string theory and 11-dimensional supergravity. He claims that the strong coupling limit of Type 2 theory develops a new 11th dimension whose radius grows with the coupling constant. At strong coupling, the theory becomes the low-energy limit of M theory compactified on a circle. The Kaluza-Klein modes from this compactification, he asserts, correspond precisely to the D0 branes of the Type 2 theory, providing a beautiful consistency check. The second piece of evidence is the role of the heterotic E-ite times E-ite string theory. Witten argues that M theory compactified on an interval, a line segment, gives rise to this heterotic theory, with the gauge fields localized on the 2 10-dimensional boundaries of the spacetime. This geometric picture, known as the Horava-Witten model, provides a compelling origin for the specific gauge groups seen in string theory. Witten's evaluation is that M theory is the parent theory. Its low-energy limit is 11-dimensional supergravity, and its various compactifications give rise to all known string theories. The name M theory itself, as he subtly implies, remains evocative of a mystery. Its complete formulation is unknown. His claim is that its existence is a necessary inference from the web of dualities, a logical endpoint that unifies all known superstring constructions into one coherent structure. Section 6, the holographic principle, and the adequacy of the correspondence, the penultimate section of Witten's argument, presents what is arguably the most radical and consequential development to emerge from this synthesis: the holographic principle, made concrete in the anti-de Sitter conformal field theory, correspondence. The core claim, originating with Juan Maldacena and refined by Witten and others, is that a theory of quantum gravity in a d+ one-dimensional anti-de Sitter spacetime is completely equivalent to a specific quantum field theory, a conformal field theory living on its d-dimensional boundary. This is a stunning assertion of equivalence between a theory with gravity and a theory without gravity living in one lower dimension. Witten evaluates the mechanism for this correspondence using the D-brane framework he previously established. He considers a stack of ND3 branes in Type 2b string theory from the perspective of the gauge theory on the branes. The low-energy physics is described by n equals 4 supersymmetric Yang-Mills theory, a conformal field theory. From the gravitational perspective, this stack of branes creates a warped spacetime geometry, which near the branes becomes the product of a 5-dimensional anti-de Sitter space and a 5-sphere. The claim is that these two descriptions, the gauge theory and the gravitational theory in the near-horizon geometry, are 2 faces of the same coin. The entire dynamics of the string theory in the bulk anti-de Sitter space are encoded in the correlation functions of the conformal field theory on the boundary. Witten presents this as a complete, non-perturbative definition of string theory in this specific background. It provides a dictionary, for translating gravitational questions into field theory calculations and vice versa. The intellectual force of this claim is immense. It gives a concrete realization of holography and suggests that spacetime and gravity might be emergent phenomena derived from the complex dynamics of a low-dimensional quantum system. Section 7. The symbiotic relationship with modern mathematics. In his final substantive argument, Witten turns his attention to the profound and unexpected relationship between these developments in physics and the landscape of pure mathematics. The claim advanced here is that string theory and M-theory are not simply consumers of mathematical tools. They are a powerful engine for generating new mathematical conjectures, structures, and entire fields of inquiry. He provides specific examples to substantiate this assertion. He discusses mirror symmetry, a duality that relates the geometry of two different Calabi-Yau manifolds. This physically motivated duality led to astonishing and provable predictions in enumerative geometry, allowing mathematicians to solve problems that had been intractable for decades. He further evaluates the impact of topological quantum field theory, a simplified version of quantum field theory that he himself pioneered. He argues that these theories, while physically simple, capture the deep topological invariance of manifolds and have provided a unifying framework for understanding diverse mathematical concepts like the Jones polynomial in knot theory and Donaldson invariance in four-manifold theory. The claim is that the physical intuition derived from quantum field theory and string theory provides a powerful, often predictive, heuristic for discovering deep mathematical truths. This symbiosis, he argues, is a testament to the fundamental nature of the structures being explored. The very fact that the consistency of a physical framework based on strings and branes leads directly to deep, non-obvious mathematical theorems is presented as powerful, albeit circumstantial, evidence for the framework's internal coherence and correctness. This final evaluation serves to elevate string theory from a specific proposal for quantum gravity to a grand, unifying intellectual structure that bridges the deepest questions in both physics and mathematics. In conclusion, Witten's 2000 exposition on quantum field theory and string theory presents a masterfully constructed argument for a complete paradigm shift in fundamental physics. The work's power resides in its methodical, layered construction, where each claim builds upon the last to erect a new conceptual architecture. The initial reevaluation of quantum field theory as an incomplete framework creates the intellectual necessity for a new approach. Supersymmetry is introduced as the specific analytic tool that makes progress possible, allowing for exact, non-perturbative results. These results then reveal the profound principle of duality, which dissolves the classical distinction between elementary and composite entities and unifies disparate theories. Deep branes are then presented as the concrete physical objects that embody these non-perturbative effects and engineer the gauge theories central to the standard model. This entire apparatus finds its ultimate synthesis in M-theory, the posited 11-dimensional framework from which all known superstring theories emerge as particular limits. The culmination of this reasoning is the holographic correspondence, which provides a concrete realization of these ideas and offers a non-perturbative definition of quantum gravity in certain spacetimes, claiming it to be equivalent to a lower-dimensional field theory. Finally, the deep connections to pure mathematics are offered as evidence of the framework's fundamental and veridical nature. The essay's overarching claim, evaluated across its constituent parts, is that string theory is the answer to the question implicitly posed at the beginning. It is the structure that provides a complete, non-perturbative, and mathematically rich definition for a vast class of quantum field theories, thereby revealing a unity previously hidden from view. The work's enduring significance lies in the success with which it established this vision as the dominant and most fruitful research program in theoretical physics for the subsequent decades.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.